Good evening, Lisa.
Hi, good evening.
I have a
Mm-hmm.
doubt actually regarding this
Uh-huh.
assignment 12. Okay, so
Okay.
in assignment
Mm,
12, question number
mm.
2,
Assignment 12,
I think
question 2. Yeah.
none question 2, yeah.
Mm-hmm.
I think no answer is there in the options. Matlab, no correct answer is there in
Correct.
the options.
Okay,
Yeah,
let me see. Just a bit.
yeah.
Okay. And have you got your assignment 12, I mean, evaluated?
Not till now.
Okay,
The
okay.
submission date is this Wednesday actually.
Oh, then it's fine. If there's no correct answer, then
Yeah.
you'll, um,
Please look after that matter. Yeah.
yeah, yeah, yeah. Just let me look at the question. Which group of instructions do not affect the flags? So,
Yes.
answer should be. I think I had this question in my practice problems also. Isn't the answer data transfer?
Data transfer and control transfer same?
Data transfer and control transfer. They should not be. Let me see. So, actually, I've not gone through the entire lecture this week. Let
Actually,
me see.
control transfer as per the lecture.
It's a wait second. As per the, I think there must be some, I don't know, some mistake there, but data transfer instructions do not affect the flags. That is the correct answer. But there must be something with the lectures.
In the lecture, it is said that the control transfer instructions don't affect the flags.
So that must be somewhere. That's where the problem is, maybe. But actually, data transfer instructions don't affect the flags.
Okay.
And I think control transfer, they are saying. Let me
Control
just.
transfer means call return that type of
Yeah,
instruction.
yeah, yeah. Ha. Control transfer. Yeah, they're not same, but maybe sir missed on saying that data transfer instructions also don't affect the flags. Maybe that's the case.
Okay, I have just today finished the lectures, so that's why
Ah,
I got that doubt. But it is not said there that data transfers also not affect the.
but yeah. That must be the problem. He must have missed it, but yeah, data transfer don't affect the.
Okay.
Yeah. Okay, so are you able to see the screen?
Yeah, it's clearly visible.
Mm. Mm. This will be a short session again. Mm. It has not
Hello.
Hello.
Yeah, you are visible.
I'm having some problem with the audio. Let me
Is
Yeah,
check.
audible.
it's clear. Yeah, but you may off one of those two, no? One of those two.
Yeah,
Yeah,
just a
just a
minute.
minute. Hello. Am I audible?
Yeah, audible.
Alright. Just a minute. I'm not able to see the screen and the recording.
But it's clearly visible, the screen.
Yeah, to you it's visible. I actually need to see if record in screen recording the screen is not visible actually. What will do? Right. Make that screen. Mhm. Yeah. No. All right. Ready to go. So, hi everyone. We'll be starting with the week 12. Let me see if someone is. I'll start with the week 12's lectures last week of this course, Microprocessors and Microcontrollers. And we'll begin with somewhat a brief summary of this week's lectures. So, first of all, just in continuation with the last week's lectures. Um, so there was this timing diagram of ADCs that was discussed. So picture is shown here. Are you able to? Okay, you won't be able to see my pointer, right?
No, it's visible.
Visible?
Yeah.
Okay. Yeah. So this is the timing diagram for an ADC. So chip select should be is active low. When it goes low, the your chip will take in the analog signal. This is given. This happens when this right signal goes low, and it just takes in this that analog signal and then converts it. Starts the process of conversion of that analog value to the digital value. And whenever the processor is done with the done with the ADC is done with the, what do you say, a conversion from analog to digital, this interrupt line will go low. Okay. And when this interrupt line goes low, the read line will go low because it is low. What do we say? Read is low enable, right? Yeah. So as soon as the conversion is complete, this read pin will go low so that the output, that is digital output, will be sent to the D0 to D7 lines. So I mean, we have done these kinds of time diagrams previously also. Then came the DAC, digital to analog converter. Examples were given by Sir when why do we or in what situations do we need DACs. So what happens is your binary numbers given on data lines D0 to D7 in case of 8-bit DAC are converted to reference IRF current, which is the analog corresponding analog value. And the conversion was also given in class. Then with this help of DAC, we saw how you can generate ramps and sine waves. Then we need to, the resolution of the DACs is actually what? Can anyone tell me? What would be the, if DAC is 8-bit, takes in 8-bit input. So what will be the resolution of your digital to analog chip? I think it wasn't mentioned there. I should have had written here also. So resolution is 1 divided by number of bits of the digital input, right? Similar logic from, I mean, you must have seen resolution in different contexts, but here, so number of digital input pins, uh, let's say this is your 8-bit DAC, so resolution will be 1 by 8, right? 1 by 2 to power 8.
Yes, 2
Yeah,
to the power
yeah,
something function of number of binary inputs.
yes. Function of number of binary inputs, so it becomes 1 by 2 to power number of your input lines. So that's the resolution. And the DAC that, so I discussed what DAC 0808. Uh, yeah, that's it from there. Then we have LCD interfacing. Mhm. Okay, so I think it was clear how you can create these sine waves and stair ramps waves with the DAC conversions, right? You just count up until the max value, and depending on what kind of wave you want, you'll be, yeah, you'll get your desired wave. So, I forgot to put in this formula. How do you get a sine wave from given uh, range of voltages? So what happens is if you want to generate a sine wave, you'll need to have values of sines of the angles that you want to plot your points for, right? It can't be continuous, so you'll have discrete points where you'll have the value of the sine function. So what happens is you have the discrete points that will be your angles. Then you'll have their sine values, and those sine values will be converted to the voltage output. Let's say you want to convert in between the range of 0 to 10 voltage. So these sine values will be what do you say, mapped from -1 to 1, which is the range of sine, to your voltage range, which is 0 to 10 volts. And then the DAC counts will be calculated from that voltage output range. And it can be useful to calculate voltage for number of steps per voltage. Let me see some. Okay, so yeah, that's how you make sine wave. If you want to, if you remember the kind of sine wave you got, I mean, from the example in class, it was very, I mean, it's not really continuous and not the way you expect sine to be. It's just an, no, qualitatively it looks like sine, but it's not sine, right? So if you want it to look more continuous, you need to increase the number of angles that you are calculating your sine values for. Just that. Um, that's it. There was this program to, how do you get this sine wave? Short, easy program. Then, LCD interfacing. So, what is the advantage of LCD over LEDs? I think it was discussed.
LCDs have declining prices, and their ability to display of number of characters and graphics are better than any other display devices, and
Mhm.
easy to program here.
Yeah, all of these, but one important that I think is, I mean, these are important also, but you in LCDs you have these internal registers that hold your pattern values, right? So that helps in reducing the, yeah. Okay, so next we had LCD pins, VSS, CC, VEE. All of these, I think you know. Then, there was this register select. So if register select pin is 0, your instruction command code register is selected, and if it is 1, your data register is selected. So that, I mean, the name is evident enough what register select is. Then you have enable a pin for to enable LCD to latch data presented on data pins. Read write, you know, one for reading, zero for writing. Then there were some other uh, pins. LCD initialization. Before that, you had some of the LCD commands. Uh, Simple enough, nothing to be explained about them. LCD initialization. So yeah, this is I think example. Yeah. Okay, so you send 38 to 8-bit data line for initialization, send 0F for making LCD on, blinking, cursor blinking on, 06 for increment. So depending on what kind of operation that you want from LCD, you can send in these codes, and the commands were discussed for different operations in the uh, lectures. Then interfacing program was discussed. I'm not doing it here. Then yeah. So next we had your another microprocessor. And I mean, it's really huge. You are doing this many processors in single course. So 8086 is a
And
microprocessor.
in a single lecture, what means in a single
Yeah,
module also, it's too tough. It's too tough
yeah,
to take that.
actually, really, it's. I mean, I think this is sixth processor you are doing.
Yeah, yeah.
Yeah, I don't know. I did all of this in 2 courses, so hats off to you guys. So, starting with 8086, this is the advanced version of 8085. Architecture is almost same. There are just some additional functions that are introduced in 8086. Um, so it's a 16-bit processor and it has 40 pins. And there's no internal clock, which means external asymmetric clock sources there, which with the 33% duty cycle. So by now you must be knowing what 33% duty cycle means, right? So yeah, it has 20-bit address to access memory, and which means it can access the typo. So it can access up to 2 to power 20 memory space, which computes to 1 megabyte, 1 MB. Uh, what else have I mentioned? Yeah. So yeah, 1 megabyte of memory space. So the addressable memory space is organized into banks of 2 banks, 512 KBs each. Even bank and odd bank, they're named this way, and address line A0 is used to select which bank you're going to use. And the control signal BHE is used to access the odd bank. Okay. Then 8086 uses separate 16-bit address for IO map devices, which means it can generate 2 to power 16 addresses, which computes to 64K addresses. And yeah, there are two interfacing up. There's a typo there. Um, Oh no. I Then recording the wrong screen all the time. Just a minute. Just a minute. Yeah. Is it visible now?
Yeah, visible.
Okay. Sorry about that. Uh, okay, so we have 16-bit address line for IO devices. Then you have these operating modes. I think this interfacing shouldn't have been here. Um yeah, so minimum mode and maximum mode, which is decided by this MNMX pins. So what, I mean, we can come to what are these modes, okay, later. Then you have bidirectional address data bus. All of the address lines and I mean data lines are multiplexed as opposed to 8085, in which you had only lower order bus multiplexed. Since here you have a 16-bit address bus, you have to have all of this multiplexed. Then lower order address bus. What have I done? Okay, ignore this one. The AD lines are used to transmit memory address, and symbol A is used instead of AD, for example, here for the address. And the data, when the data are transmitted over AD lines, the symbol D is used to place in place of AD, for example, given here. Just a minute. तो ये मेरा 8 साढ़े 8 बजे तक चलेगा फिर मैं कॉल करती हूँ ठीक है क्या ठीक है करती हूँ मैं रुक जा where was we? So yeah, when data is you know the nomenclature how the lines are used. Then these A16, 17, 18, and 19 are further higher order address bus since you have a 20-bit address now, right? So they are multiplexed with these status signals. Then, so address data bus I have discussed. Ah, so this BHE active low S7 is the output signal. So what is BHE? Are you able to hear me?
Yeah, you are audible.
Yeah. So what is BHE signal?
It is
I've written it below.
bus
Hmm.
high enable signal.
Uh,
It is used to enable the data onto the MSB, means most significant half of the data
mm,
bus. that is
Yeah.
D8 to D15, and this 8-bit device connected to the upper half of the data bus use BHE signal.
That is why it can,
It's
I mean,
yeah, it's
put data
much
onto D50.
yeah.
Oh, yeah, so that's that. Then you have this MNMX pin, which indicates in which mode the processor is operating in. So MN is for minimum, MX is for, yeah, maximum operating mode. So in minimum one, the microprocessor does not associate with any co-processors, right? So, and in the maximum operating mode, the 8086 can work as a multiprocessor configuration. You can have multiple processors connected and it can work with them. And this can be changed by this MNMX pin. I think all of these are for retest reset. Mm, mm, I'm sorry. Not sure. Okay, so this read signal is active low used for read operation. Test is input, I mean the function is to wait. So 8086 will enter a wait state after execution of this wait instruction and will resume only after test is made low by the active hardware. Okay. Then reset is it causes the processor to immediately terminate the present activity evident by its name. Then you have clock, interrupt, and yeah, so different signals of minimum mode and maximum mode signals were discussed. So, yeah. Can you remind me what were the signals? Just list out the signals for minimum mode.
They are minimum mode signals. They are DT slash R bar,
Mm-hmm.
then
Okay.
DEN bar,
Got. Yeah. So, DT slash
data
R bar is
transmitter
for
receiver.
transmit receive.
Yeah,
Yeah. DN
yeah.
for your data enable. ALE,
Enable.
as you know, what is ALE? Address latch enable. Memory input output. And yeah, someone is asking for PYQs. Is it for the final exam? Are you asking for PYQs of the exam from last year? I'm sorry, someone texted. Yeah, for NPTEL exam, right? I don't have previous year questions for the exam. Uh, Sorry for that, but this will be on same lines as your assignments have been. So I don't think we'll have much problem in that. But yeah, I don't have access to previous year's questions. Sorry for that. Okay, so yeah, you have DTR, D, and ALE signal memory input output, right? Interrupt acknowledge, hold signals, hold acknowledge. Similar as you remember what hold and hold acknowledge are, right?
Yeah,
So yeah, so whenever your input signal to processor from bus master is asking to release control of your buses, it sends the hold signal and hold acknowledges acknowledging of that signal. Then yeah, yes. Then you have these control signals for maximum mode also. For that you have these status signals S0, S1, S2, and these status signals are used by 8086 to generate, yeah, bus timing and control signals. Then you have this queue status. Since in maximum mode you have multiprocessor configuration, so you need to have this queue status to I mean, you cannot acknowledge all of the processes. I mean, serve all the processes at same time, right? So queue status will help managing those. Then bus request, bus ground, they're all. Then you have this lock signal. Yeah, lock is enable low, and it is an output signal activated by lock prefix instruction. So output on lock bar pin. Um Output is low on lock pin when the instruction with prefix lock is being executed. And what does this mean? This prevents the other masters from gaining control of your bus. So that's that. Then you had the architecture. So here's a picture of the architecture. I mean, the whole system is broadly divided into this execution unit and interface unit. Bus interface unit. So execution unit executes the instructions fetched by your bus interface unit, and the bus interface unit will fetch those instructions. So as you see, you must be knowing by now. You have ALU for execution of your instructions here, and address generation kind of similar operation than as ALU, but what it does is generates these 20-bit, 16-bit addresses, 20-bit addresses, because all of these are 16-bit, and how you generate 20-bit addresses by adding offset to your these 16-bit register values CSDS, SSCS. So that addition of offset to your values of these registers is done by this address generation, this um, block here. And what else? Uh, yeah, so it's a four segment. It has four segment registers. You can see here. These orange one are segment registers. CS value and IP value combined to give your 20-bit address. And your 20 MB, what have I written? Mm-hmm. So yeah, 8086 can directly address four of these segments within MB of memory range at a particular time. And the way it is written is also discussed in class CS colon IP to access the next address of the next instruction. And how do you form 20-bit addresses? Can anyone or does anyone want to explain? Easy. How do you generate 20-bit address?
IP plus CS constituting this 20-bit
Yes, but
address.
IP is individually 16-bit. CS is individually 16-bit. So you shift your CS, multiply it by 16 or shift it by 4 bits, whatever you like to say it. And lower you'll get four zeros at the as the lowest order bits, and for IP you add four zeros at the highest order. I mean the max MSB side, and then you after getting these 20-bit values of both of these modified CS and IP, you add them, and that is your eventual what do you say 20-bit address. Uh, yeah, this is done. Then you have this was for code segment register. The data segment register work. This is, I mean, code segment was for program fetching in program. Data segment is for address of the data. Similar way, uh, yeah, the way you generate address here, similar way you will generate address with data segment register also. Uh, Same, you have stack source, stack segment register, extra segment register used to point to data location other than the data segment that you are currently using. So, Uh, yeah, this instruction queue is important because you didn't have this one in 8085. So what happens is this is just like works like pipelining. So while one instruction is being executed here in the execution unit, your bus interface unit will do what? Stack up all the instructions in this instruction queue. So, so that while the one instruction is being executed, the next ones are already fetched, and there's no time wasted in fetching those instructions. So works like pipelining, and the instruction queue is simple. It will come from here and keep shifting on to the next subsequent. What do you say? Location, and if it's come in here first, it'll go out first. So first in, first out pipelining. Then okay, yes. So this while the instruction is sent to the execution unit, it goes to internal control system, which is also the decoder. It decodes the instruction, and the decoded instruction through these lines will go to the ALU. Um, I mean, the process that you've learned in previous processes will happen again, and then you'll get your answers result. Oh, so it has segment registers. Yes. So registers are given here. It has 8086 has four general purpose registers shown here: AX, BX, CX, TX. These are all 16-bit and can and have 8 bit individual two parts, 8-bit, 8-bit. For example, AX has AH and AL, higher and lower part of the register. Then you have pointer register, which is 16-bit, index register 16-bit, SID. These are the, names of the corresponding 8-bit. Then instruction pointer 16-bit, segment register. All of these are 16-bit. You have flag registers. You have numerous flags for 8086. Then what are here? The name of the register and their functions. These are also given here. Yeah. So, yeah, these are the registers. Nothing much to see here. Then, so these are just one line descriptions of what these addressing, since there are numerous addressing modes, one line descriptions of what these addressing modes are, or a special thing about the addressing mode. For example, you've seen register addressing, immediate addressing, direct addressing. Which ones are new? Uh, I've written register indirect twice, right? Hmm. So, yeah, string addressing is new, is employed in string operations to operate on string data, right? So the effective address, what is effective address? Anyone? I just discussed it. I just didn't use the word explicitly. So you need to form these 20-bit addresses, right?
Yes.
Mhm. So effective address will be the address that you formed, right? Because all of your registers are these CSDS, all are 16-bit registers. So they can carry only that much of information to get the complete, the exact address or the effective address, as you'll say it. That is why it's called effective address of the correct location uh, by forming 20 bit is called effective address. Then that's your string addressing. IO port addressing is same as you just access the IO map devices or ports through their addresses. Then you have relative addressing. In this addressing mode, the effective address of the program is specified relative to the instruction pointer. So your instruction pointer will have some value, and the address will be given as a relative value to that instruction pointer. Implied addressing, you know. Then, yeah, some of the instruction sets were discussed. I think they were, yeah. Generally, you have data transfer, method logic, string manipulation instructions, process controls, and control transfer. I mean, it's not really, you can't really remember all of this. So don't, I mean, there's no need to rot learn all of this. You just need to understand what kinds of instruction these are and what they do. Okay. So, yeah. I mean, this is a very logical subject. You're not supposed to learn things. But since you have so many processes, you'll have to with just keep your clarity. I mean, what these instructions do. And I think that should be fine. Just a minute. Yeah. So practice problems. Can you see the screen?
Yeah, it's visible.
Okay. So yeah. So which groups? Oh, this is the question you were asking me, right? Which group of instructions do not fit the flag? So Priyanka just asked me a question before starting the session. You have this question in your current assignment also, right? I didn't know. So I think sir missed it during the lecture, but he said which ones did he say? Control.
Yes, control.
So I think he missed on saying that data transfer instructions also do not affect the flag. So data transfer should be the correct answer in this question. Oh, where's the
Okay.
pen? Yeah. Wait. Hmm. So data transfer should be the correct answer, but if there was a control transfer also, that would have been the correct answer also. Just to note this one. Okay. Next is which of the following microprocessor accepts the program written for 8086 without any changes?
8087.
8087 or 88?
I'm confused.
I think it's 8088.
88.
So 8088 will take in the program without any changes. Then, yeah. So which of the following statements is false regarding 8087? Anyone?
Is it option D?
So 8087 cannot multiply 128-bit real numbers. I mean, what is the maximum value of bits? Maximum value of bits of numbers that 8087 can multiply.
It can multiply up to 264-bit real numbers.
64 bit, right? So it
Yeah,
cannot multiply 128-bit real numbers.
yeah.
Oh. D is the correct answer. Then we have. So, what is the maximum amount of memory that 8086 can address?
1 MB.
1 MB. Why? Because 20
It has it has
bus,
two
right?
banks. Yeah, 5
20-bit
and
bus.
12 KB each. That's right. Two into that. So 1 MB.
Yeah. So 2 to power 20 gives you 1 MB. Next is which flag in 8086 is set by STC instruction?
Zero flag.
No, STC
Oh, carry flag. Carry. Oh, carry.
carry flag, right? So STC will set the carry flag to 1. Ne- What is the purpose of BHE signal in 8086? Just discussed it. The purpose of BHE signal is to enable higher byte of data bus during the memory use, right? Everyone okay with this? Yeah. Next is which of the following signals is used to synchronize test pen with the clock signal of 8086? Yeah, this is ready. I didn't know. Okay, so to synchronize test pen with the clock, ready pin is used. Ready signal is used. Okay. Old reset INTA, all of these you know already what they mean and what their function is. Ready was this new one, and it is used to synchronize test pen with the clock signal. Okay.
Yeah.
So, what is the function of M and MX? This is easier.
Number one.
Number one, it selects the operating mode of the 8086 processor. That's it. Which of the following modes is preferred when 8086 is used in multiprocessor system? Mode. Don't say the full name.
Maximum mode.
Maximum mode. It can have multiple core processors. Is my question. It can have multiple core processors, and that's basically your definition of maximum mode. Then, what is the function of instruction queue in BIU?
Is it option C?
Option C is to store interrupt requests. No. In instruction queue, remember? We just discussed. Just, I mean, imagine the picture, or I can just go back. Yeah, here. Remember we discussed the instruction queue in DIU in unit. So what is the function of this instruction queue? So, first of all, it works as pipeline, right? I mean, this is kind of pipelining in 8086. So while one instruction is being decoded here, internal control system, and while the operation is being done, this BIU will do what? Just keep on fetching the instruction while this instruction queue has space and keep on stacking those instruction here, right? So
Okay.
that you remember how pipelining worked, right? You
Yeah.
I- you fetch one instruction, decode another, and execute another, right? So while some previous instructions are being executed here or decoded here, the BIU interface will keep on stacking the next instruction in this instruction queue so that whenever this internal control system is done with decoding the previous instruction, it can directly have the next instruction. It doesn't have to wait for fetching the next instruction. That waiting will be done here, and the your processor won't I mean won't know that this fetching is being done because it's constantly being fed by instructions from this instruction queue. Okay,
Okay. Got it.
so going to a question. So what's the function of instruction queue?
Option A.
Option A, right? To store the
Yeah.
instructions for
Execution by the.
execution. That's yes, correct. So which of the following segment registers is used to hold the offset address of the current instruction? Remember, it's not the, the question is about the offset address, not the address of the segment. If it was the address of the segment, that would have been CS, right? Ah, I don't
SI, I think.
know. Okay, the options are wrong actually. That's what I was thinking. So the option should have been IP, remember? CS combined with IP gives you the total address. CS has the address of the segment, starting of that segment, and then IP is added to that because IP has the offset of the address. So the options are wrong. Correct answer should have been IP. Check it once. No, I'll check it once again and then I'll upload the PPT. Okay. I think IP should be the correct answer and it's not there in the options. Remember how you form your 20-bit addresses?
Yeah, 16-bit plus the 4-bit.
Yes. So CS is shifted by 16 and IP is then added to it.
Yeah.
So that IP is added because IP contains the offset of the address and CS contains the starting of the that block segment. So answer should be IP. I'll check it once and then I'll upload it. Then you have this instruction move AX 1234 hex. So what addressing mode is used in this instruction?
Immediate.
Immediate addressing mode. So you're immediately, the number is given here and it has to be moved to this register AX. Image addressing mode. Immediate. So what addressing mode is this? Move DL BX.
Register addressing mode. BX.
I think this is indirect addressing mode because this,
BX in bracket. That is a memory uh,
yes, pointing. Yeah,
pointer.
yeah,
Yeah, yeah.
yeah.
Mm.
I should have written it clearly, but yeah. So this is indirect addressing mode. So DL will get the value of memory location pointed by this PX register. Okay, that's your routine. Next is what is the purpose of DT R pin? That should be R bar.
Data reader right. C option.
Yeah.
Timing the memory. Yeah, right option.
So DTR is the input output pin that controls the direction of the data flow, whether you're going to write it or read it, or in the nomenclature, transmit or receive it. Okay. So C is the correct answer here. Then, so which of the following status signals indicates the processor is currently waiting for a device to respond for interrupt request?
Test.
Interrupt request now.
Oh, interrupt. Then INTA.
INPA, right?
Mm.
I know
Mm.
this is confusing. You just need to, I mean, the way to understand it, just all similar kind of pins or signals, you just write down and write their functions or operations, and then you'll have a clearer idea which one is used for which one. I mean, in test also you thought it's for acknowledgement of that waiting, right? But
Yeah,
just
little
read
bit
the questions.
confusing.
Yes, read the questions and just segregate what are the different, I mean, the points that are different from others. Like what is different from test, what is different in test and INTA, and you'll have a clearer picture. It's not difficult, you just need to put it there in your copy. Oh, that's it, yeah. That's it from me, from this course and today. Uh, you, I mean, yeah. So you must be having your exam, right? There's all of the assignments are done.
Yes, ma'am.
So
Not
all
done.
right.
12. 12 is not done.
Ah, okay.
Yeah.
So yeah, all the best for your 12th assignment and your exam. And this is my email address. You can contact me if you have any questions or queries, and I'll be there to respond. That's it. Thank you for bearing
Wait,
me
wait, wait,
this
wait.
whole
Need
course.
to write
Yeah,
this. Wait.
yeah. I mean, the email address is there in all of the previous PPTs also.
Yeah, okay.
All
Thank you.
right.
Good night.
Good night. Thank you. Bye bye. All the best.
Thank you.
Thank you, ma'am. Good night.
Good night.
ये लूज ही पहनते हैं सारे।
मेरे को पता मैं
हाँ
तो वैसे ही ज्यादा फिटिंग वाले मैं पहनती हूँ।
ये जो ये वाले हैं ना चिकन वाले, ये लोग क्योंकि ये वो है ना अंदर से, क्योंकि आप फिटिंग वाला पहन लोगे क्योंकि ये ट्रांसपेरेंट ही होते हैं, तो इसको लूज ही पहनते हैं लोग।
तो ये मैं सोच रही हूँ, देख आगे तो जरूरत नहीं इसको वो लाइनिंग की, देख